Hello everyone, I am about to present our work, Hybrid Style Siamese Network, incorporating style loss in complementary apparels retrieval. In any sort of an e-commerce website, we have come across image retrieval techniques that suggest us apparels based on our choices. Now there can be two types of retrieval here. Similar items retrieval, where the system or model suggests items which look very similar to the chosen one, or complementary items retrieval, where the model suggests an item that goes with or is compatible with the chosen item. One of the dominant methodologies in image retrieval is Siamese networks coupled with triplet loss. Siamese networks convert an image to an n-dimensional representation in a latent space, whereas triplet loss aims to bring similar images closer in the latent space while increasing the distance between dissimilar images. Now this was in a case of similar items retrieval, but in complementary items retrieval also, Siamese networks have been found to work just as well. This is the case that we will explore in our paper. The backbone architecture of the Siamese network can be anything. In our paper, we have used VG16 architecture as the backbone. We propose a hybrid Siamese network that introduces a style network component alongside the usual backbone architecture. In neural style transfer, gram matrices are computed over the initial few layers, and these serve as a notion of the style of an image. Taking that intuition into account, we compute auxiliary outputs from the gram matrices of the initial 4 layers. These auxiliary 4 layers are fed into the style loss, whereas the main embedding output still serves as the latent representation of the whole image. This is our style network. It is important to note that we pass the feature maps from the initial 4 layers through batch normalization in order to restrict the feature values to a small space. It thus prevents the style loss to go out of bounds during training. The auxiliary outputs from the positive and negative images of a triplet are fed into the style loss. This is because we expect there to be stylistic dissimilarities between these two apparels. Since the negative of the traditional style loss of neural style transfer is used in our case, a bigger difference in style leads to our style loss being smaller. The main embedding output of all three apparels of a triplet is fed into the normal triplet loss, and weighted sum of these two losses, the main loss and the style loss, thus constitute our hybrid triplet loss. The intuition behind the whole idea of the style loss is that if an apparel A goes with a certain apparel B but is not compatible with an apparel C, then we can expect that apparels B and C are stylistically different from each other. We evaluate our methodology on the iMaterialist dataset. It comprises of people in real-life scenarios and the associated information of the apparels that they are wearing. In order to do justice to the evaluation, we use pixel-level segmentation information to strip the image of the visuals of the background scene so that it doesn't affect the model in any way. Ultimately, we form triplets out of the dataset and train our model. For our primitive work, only the pair of t-shirt and skirt is taken into consideration for evaluation, since this gives us a wide variance in style, which is not possible in case of other pairings of categories. We compare our model against the traditional Siamese network as explained by Veit et al. To ensure a fair comparison, we use VGG16 model pre-trained on ImageNet as the backbone architecture in both the cases. Also, for robustness, we run 3 separate trials with 3 separate randomness and use the cross-validation map score of each. Our methodology obtained a performance increase of nearly 3% over the traditional Siamese network, which goes on to prove its effectiveness. Since taking style into consideration for image retrieval hasn't been explored that much, we wanted to start the work with a small but robust experiment. The work and experiments are out to be extended further in the future, as it is something that we believe has potential. not just complementary items retrieval, we believe it will be beneficial for similar items retrieval also, where style also does play a major role. The code for the paper is available at the link given in GitHub. Thank you.